Hi, this is Alex from devstories.eu. SQLAlchemy, Episode 7 of 7. Relational databases exist because data connects, but writing complex joins manually every time you need a related record gets old fast. You end up with repetitive query logic scattered across your application. Connecting the dots, relationships, and joins solves this by letting the object relational mapper handle the connections for you. At the database level, tables connect using foreign keys. If a user has multiple addresses, the address table has a column storing the user ID. That is a standard one-to-many relationship. But when you write Python code, you do not want to extract an ID and write a second query just to find those addresses. You want to access a property on your user object and instantly see a list of address objects. This is exactly what the relationship construct provides. It bridges the gap between database foreign keys and Python object attributes. To set this up, you need two things. First, you declare the foreign key on the database side. In your address model, you define a column called user ID and explicitly mark it as a foreign key pointing to the user table. Second, you define the relationship on the Python side. In your user model, you define a property called addresses using the relationship function pointing to the address model. You also define a relationship property on the address model pointing back to the user. Here is the key insight. SQLAlchemy needs to know that these two properties represent the two sides of the exact same connection. You tell it this by using the backpopulates parameter on both relationship definitions. On the user model, the addresses relationship sets backpopulates to the string name of the user property. On the address model, the user relationship sets backpopulates to the string name of the addresses property. Because of backpopulates, the ORM keeps your Python object synchronized in memory. If you take an address object and assign it to a user, that address instantly appears in the user's list of addresses. The framework handles the bookkeeping before you ever commit anything to the database. Once your objects are linked, you query them. Suppose you execute a select statement to find a user named Alice. The database returns the user row and you get an object. At this exact moment, Alice's addresses are not loaded. The ORM does not fetch them because you haven't asked for them yet. When you finally access the addresses property in your code, perhaps to iterate over the street names, the ORM notices the data is missing. It automatically pauses your program, emits a second select statement to the database to find all addresses with Alice's ID, and populates the list. This is called lazy loading. It is the default behavior because it prevents the application from pulling thousands of related rows into memory unless they are strictly required. You query a user, you access their properties, and the system seamlessly navigates the foreign keys and issues the necessary queries in the background. The real power of the relationship construct is that it hides the mechanical complexity of joins, letting you navigate an entire database just by interacting with connected Python objects. To master these concepts, explore the official documentation and try setting up your own models hands-on. Feel free to visit devstories.eu to suggest topics you want covered in future series. That's all for this one. Thanks for listening and keep building.